Hello, it's Dumplet here. Welcome to part 18 of 25 of the College Entrance Test Review. Credits to the review masters for providing me with these items. To continue, if the sides of a quadrilateral are 8, 14, 12, and 20 centimeters, and the longest side of a similar quadrilateral is 30 centimeters, how long is the shortest side of this quadrilateral? Now, one thing to note is that if we have similar polygons, well, in this case, a quadrilateral, and we're given with sides, we know that the ratio of the sides is constant. So it's, for example, 20 here will correspond to 30 because, well, 20 is the longest side of this quadrilateral. So 20 would correspond to 30 as given. And we know that the shortest side would obviously correspond to the value that is asked in the problem. So the shortest side of this quadrilateral. So we know that the ratio of 8 is to x, so I'll just write 8 over x. 8 over x, that's equal to the proportion or the ratio of the sides. And this will be equal to 20 over 30 because that's also the ratio of the corresponding side. So make sure that the corresponding sides are correct before we build the ratios and the equations. So after we build the equation, it's just a matter of solving for x. So 20 over 30, that's obviously 2/3. So, 2/3. So all you have to do is solve for x. Now, we can cross multiply. So we're going to get that 24 is equal to 2x. And just solve for x here, we're going to divide both sides by 2, we're going to get that x equals 12. So the unit is centimeters, so we have choice B as our answer to this item. For item 70, in the figure, the ratio of the area of triangle LEA to the area of rectangle LAST is, and we have 4 ratios. Now, apart from the fact that it's given that E is on ST, there's no other given. So we can try to use this fact again. So since the answer is numerical, it shouldn't matter where E is because it's not really stated as to where E is. So we can abuse this fact and then we can try to make E in the middle. Now if E is in the middle, then I can easily do my analysis because I can easily separate parts of this figure. So note that LEA for my figure, well, this part is exactly half of this rectangle here, and this part, it's exactly half of this rectangle here. So the answer seems to be 1/2, and it is 1/2. So I'll write 1:2 as an answer. Now, what's funny is that I've mentioned that E doesn't matter. I mean, the position of E shouldn't matter. So I can make a very obscure one. So let's just say point E is super close to point T. Well, in fact, let's just make E and T coincide at one point. So T and E. So let's say this is E. Now, what is triangle LEA now? Now, triangle LEA would have to be this triangle over here. Now, if this triangle is triangle LEA, then I guess it will be obvious that, well, this part is the same as this part. So, well, indeed, this is much more convincing that the answer is indeed 1:2. So then again, just like with the variable givens, we can try to substitute. Or let's a specific value. For this, it's not really given where E is, so you can try to do whatever you want. You can place E wherever you want, and we should be able to get the answer. So either it's in the middle, or like in this case, a very extreme, so putting E literally at the same point as T. So it's up to you guys, but you should be able to get that the answer is 1:2. Next, for question 71, point A is the midpoint of the line OAK. So I'm just going to write, I'm just going to connect here OAK. So, so OAK. We're always at the origin. The coordinates of K are, so again, this figure is not drawn to scale. I couldn't connect these three with a line, but we can use the fact that since A is the midpoint, we can use the rise over run technique. So from O to A, I'm moving 5 units right, and then 3 units up. So from 0, 0, I move 5 units to the right, and then 3 units up to reach this point. Now, since A is the midpoint, I should do the same to A, and then I will be able to get K. So I should also move 5 from A. So move 5 units from the right to the right from A. So this part here would be 5. And then I should move 3 units up. So I'm just going to write here 3 units up. So I should hit K. So I should move 5 units to the right and then 3 units up from this point, 5, 3, to reach K. Now, moving 5 units to the right, we're going to add 5 to the value of x. Again, we're going to the right, so we're going to add x, so because we're going towards the positive x direction. So 5 here is the abscissa, or the x-coordinate of A. So I'm just going to add 5 to it, and I'll end up with 10. And then for the ordinate, or the y-coordinate of this point, I'm going to add 3, since I'm moving up, again, going towards the positive y direction. So I'm going to add 3 to this 3. So it's going to give me 6. So I should get that the coordinates of the point K is going to be 10, 6. And this corresponds to choice D. Item 72, the perimeter of a square is 24. So just from that fact, we can already easily solve for S, or the side of the square. So for S is 24, so S should indeed give us 6. And we're asked for the length of the diagonal of this square. Now, since S equals 6, this will be 6 and this will be 6. And using the fact that we have right triangles everywhere in a square, we have 4 right angles over here, we can use the Pythagorean theorem to solve for this green segment, which is going to be the length of the diagonal of the square. Now we can easily do the Pythagorean. It's going to be s squared, so I'm just going to write 6 squared plus 6 squared equals, let's just make this d for diagonal squared. So we have 6 squared is 36, so 36 plus 36, that gives us 72. 72 is equal to d squared. Solving for d, we're just going to get the square root of 72. Now 72 comes from 36 times 2, so if we want to get the square root of that, we know that the 36, we can put it out as 6. And then for the 2 here, well, there aren't any perfect squares anymore, so we're just going to write 3 square root 2. So from this, actually, we're going to get that d equals 6 square root 2. Now here's a nice shortcut. If you have the side length of a square, if you want to get the diagonal of a square, simply multiply this by square root of 2. So like from 6 over here, if you want to get a diagonal, just add a square root of 2, or just multiply it by square root of 2. So that's a shortcut. So we have choice B over here. Now, just an example, if this wasn't a 6, instead it was given to be, for example, 297, then without using the Pythagorean theorem, we can easily conclude that the diagonal is going to be 297 and just multiply a square root of 2 to it. So that's the shortcut if you want to get the length of the diagonal of a square. So hopefully you guys learned something new from this video, and I'll see you in part 19. Bye-bye!